In 1973, Detroit's Big Three automakers submitted a formal verdict to the U.S. Congress. Cutting internal combustion engine emissions by 90% defied the laws of physics. Months later, a Chevrolet Impala equipped with a GM 5.7-liter V8 engine shattered Detroit's technological monopoly. The man who broke it wasn't an Ivy League engineer, but a bottom-tier mechanic who never finished high school and once cleaned waste oil out of the dirt. Soichiro Honda. Forget the Silicon Valley myths about multinational founders. In the underlying logic of modern industry, an empire's starting point is never a spotless R&D center. It is a scrapyard, defined by lethal mechanical noise, toxic exhaust, and physical wear and tear. Tokyo, 1922. Class barriers were impenetrable. The terminal mobility market was being ruthlessly crushed by the assembly lines of American Ford and GM, while domestic heavy industry was entirely locked down by massive conglomerates like Mitsui and Mitsubishi. For a 15-year-old broke kid fresh out of the rural Shizuoka prefecture, a kid who didn't even qualify as cannon fodder for the military due to mild color blindness, there was only one path forward: submit to the physical conditioning of the industrial scrapyard. Carrying a battered wicker trunk, this teenager, Soichiro Honda, walked into Art Shokai in the Yushima neighborhood of Tokyo's Hongo ward. It was a repair center exclusively serving the extreme elite, its garage filled with Lincolns, Mercedes, and Daimlers. None of that had anything to do with him. For his first 6 months on the job, Honda's physical coordinates were locked to the garage's dirt floor and his boss's back. He was absolutely forbidden from touching any metal tools. His daily routine consisted of strapping the boss's infant to his back and pacing through deafening mechanical noise, or crouching on a rough floor devoid of ventilation or oil recovery systems, using a coarse rag to painstakingly scrape up the sand-mixed waste oil dripping from the undercarriages of luxury vehicles. It was a brutal form of sensory deprivation, but also the most primal form of baseline energy accumulation. The garage was thick with the acrid exhaust of early, inefficiently burned internal combustion engines, alongside the pungent stench of scorched castor oil used in race cars. Confined to this highly degraded environment, saturated with toxic volatiles, Honda was forced to develop an absolute physical intuition for the smell of various mechanical fluids and metal-on-metal friction. He didn't need precision diagnostic instruments. He just needed to smell the floor to determine exactly where a fatal engine failure had occurred. Large corporations expand through monopoly. The only opportunity for those on the absolute margins is to wait for a sudden collapse of the macroeconomic order. On September 1, 1923, the devastating Great Kanto earthquake struck, triggering massive fires that instantly swallowed vast sections of Tokyo. The Art Shokai garage was in imminent danger. Under the extreme pressure of advancing flames, the 16-year-old Honda, who had never formally learned to drive, jumped straight into a client's car, forced it into gear through the thick smoke, and backed the vehicle out of the inferno. It was his first time operating an internal combustion engine from the driver's seat. This physical catastrophe, which claimed over 100,000 lives, forcibly tore open a gap in the class structure. A massive wave of skilled mechanics fled Tokyo due to the devastation of their hometowns or the fear of aftershocks, sending repair shops into extreme labor shock. Squeezed by this labor vacuum, the boss had no choice but to shove a heavy metal wrench into the hands of the car wash boy. Soichiro Honda finally acquired clearance to touch precision machinery. Once unchained, this bottom-tier apprentice revealed his true nature as an absolute gearhead. In 1924, Honda participated in a highly unhinged mechanical experiment, assembling the Curtiss race car. Inside a garage devoid of blueprints or modern equipment, they dismantled the chassis of a retired American Mitchell automobile and forcefully shoved an absolute behemoth inside it. A Curtiss OX-5 aviation engine, stripped from an American WWI surplus JN-4 Jenny biplane. This water-cooled V8 engine had a massive displacement of 8.2 liters. To bear the load of a violent machine originally designed to achieve lift, the 17-year-old Honda personally carved wooden wheel spokes with a knife to reduce unsprung mass. Lacking a hydraulic press, he picked up a heavy sledgehammer and, over a custom-built wooden mold, violently beat rigid sheets of aluminum and iron into an aerodynamic shell, blow by blow. This was aerodynamics purchased entirely through pure muscle and skeletal degradation. In that era, igniting an 8.2-liter V8 Leviathan was a death-defying physical operation. It lacked a modern electric starter. A mechanic had to stand at the front of the vehicle and use pure human horsepower to crank a heavy metal handle. The staggering 8.2-liter displacement meant extreme cylinder pressure. If the engine kicked back at the moment of ignition, the rapidly reversing metal crank could shatter an adult's wrist or forearm bones in fractions of a second. Soichiro Honda's hands-on mechanical execution was performed right at the front of this car, facing the constant risk of permanent physical dismemberment. On November 23, 1924, the 5th Japan Motor Car Championship kicked off on an unpaved dirt track in Tsurumi, Yokohama. The boss's younger brother took the wheel, while the 17-year-old Honda sat directly into a cockpit entirely lacking seatbelts, roll cages, or any form of safety mitigation, serving as the riding mechanic. Pushed to maximum velocity on the dirt circuit, the rear wheels spun wildly, kicking up blinding dust clouds. When this Frankenstein machine of scrap chassis and aircraft engine ran at wide-open throttle, oil sprayed everywhere. Amidst violent mechanical turbulence, Honda had to lean halfway out of the vehicle into gale-force winds and flying debris to manually and precisely pump oil into the profusely leaking V8, even leaning out during high-speed cornering to adjust the carburetor's air intake. There was no precise laboratory data, only the most primal engagement of metal gears and gasoline combustion. This monster, pieced together from junk and manually lubricated by a bottom-tier garage kid, utterly decimated the grid and took the championship. The 15-year-old apprentice, who once carried a baby through oil-stained dirt, had, in less than 3 years, smashed open the door to the internal combustion world using the most brutal physical methods available. But this was only his first industrial checkpoint. As he attempted to scale into higher manufacturing dimensions, what awaited him was an impenetrable wall of materials science, a barrier engineered for operational death. By 1936, the 29-year-old Honda owned the most profitable auto repair shop in the region. For an average man, this would represent the apex of the so-called American dream: stable, lucrative, and devoid of risk. But for a true gearhead, being permanently relegated to fixing machines built by others is a psychological torment. He wanted to dictate the industrial standards himself. He announced to his partners his intent to manufacture piston rings. This is a component enduring the most extreme operating parameters within an internal combustion engine, subjected to thousands of explosive friction cycles per minute at temperatures reaching hundreds of degrees. His partners thought he had lost his mind. Walk away from an auto shop printing cash to gamble on a manufacturing sector where you have zero experience? Faced with derision, Honda delivered the hardest possible response. He walked away with nothing, pawned every piece of his wife's jewelry, scraped together every last cent, and brute-forced the creation of a dilapidated workshop named Tokai Seiki. He operated under the assumption that the feel cultivated from 15 years flat on his back beneath chassis could conquer industrial manufacturing. He was catastrophically wrong. In 1938, hauling his first batch of 50 hand-cast piston rings forged through sleepless nights, Honda knocked on the doors of automotive giant Toyota. Toyota's engineers threw the components into their testing apparatus and handed back a deeply humiliating physical verdict. Out of 50 samples, exactly 3 passed. A 6% yield rate. In subsequent mass production attempts, that metric plummeted to a catastrophic 0.3%. Toyota's quality control inspectors offered zero diplomatic buffer, slamming the rejection slip against his chest. Your product doesn't even qualify as an industrial component. It's just a piece of scrap iron shaped like a piston ring. It was a devastating kinetic impact with reality. Turning wrenches is a trade, but metallurgy is a ruthlessly cold science, and science doesn't operate on feel or so-called dreams. The vast majority of people, upon absorbing that level of humiliation, would tap out and crawl back to the repair shop. Honda didn't. At 32, this fiercely arrogant garage boss swallowed his pride and forced his way into a local industrial university as an unregistered auditor. He didn't care about degrees or credits. He simply cornered the professors with a single, relentless question. Why is my iron shattering? The next 2 years became a purgatory of physical trial and error. To conserve capital and exert absolute control over variables, he fired his workers and operated the unshielded, high-temperature furnaces himself. Over countless iterations of testing carbon and silicon ratios, boiling iron, reaching temperatures of 1,000 degrees Celsius, splattered repeatedly, inflicting permanent physical burns across his face and calloused hands. To precisely capture the exact thermal threshold for discharging the pig iron, he completely stopped going home. Using a pile of rags for bedding, he slept directly on the foundry floor, an environment saturated with acrid metallic dust and black sand. The prolonged intersection of extreme fatigue, sleep deprivation, and toxic gas inhalation caused his weight to plummet and his facial structure to heavily hollow out, earning him a local moniker, the Ghost of Hamamatsu. But that ghost eventually cracked the metallurgical code. By 1939, Honda finally locked down the precise ratios for introducing trace amounts of nickel and chromium into the cast iron. Refusing to rely on probability, he welded together his own heavy-duty pressure rig and subjected the next-generation piston rings to tens of thousands of violent destruction tests. When Honda slapped the new components onto Toyota's desk again, the telemetry forced the giants into silence. The new batch of piston rings not only flawlessly cleared Toyota's limit tests, but their wear resistance and compression metrics directly outclassed the top-tier components being imported from the US and Europe. The corporate titans who previously mocked him were now lining up with blank checks, begging for supply. Almost overnight, the rundown garage manned by a few operators rapidly expanded with the force of a nuclear detonation, transforming into a heavy manufacturing plant employing 2,000 workers. In an industrial landscape dominated by suited conglomerates, this scarred, burn-marked underdog brute-forced his way through the gates of manufacturing, pulling off his first absolute reversal. In the foundational logic of commerce, once you establish a preliminary fortress by scaling technical barriers, the most terrifying threat is no longer your competitors. It is the indiscriminate, crushing weight of the macroeconomic system against the individual. By 1941, fueled by his grind-to-the-bone piston ring tech, Honda had erected a 2,000-man manufacturing empire. But the era denied him the bandwidth to continue his business run. With the total outbreak of the Pacific War, the Japanese state apparatus shifted into a hyper-militarized command economy. Honda's Tokai Seiki was forcibly seized by the Ministry of Munitions. Subsequently, Toyota, acting as a major defense contractor, leveraged wartime administrative directives to orchestrate a hostile takeover of 45% of Honda's equity. Honda was stripped of all physical control over his facility. He was downgraded from the president with absolute authority to a neutered senior managing director. The highly trained mechanics he had personally mentored were drafted in bulk and sent to the front lines as cannon fodder, while his assembly lines were forcibly restaffed with schoolgirls who had zero concept of what a machining tolerance was. This was the system's first phase of strangulation, the absolute expropriation via administration and capital. Yet this was merely the prelude. If capital only severed his control, what arrived next was absolute destruction strictly on a physical dimension. In 1944, formations of American B-29 Superfortress bombers acquired the Hamamatsu Industrial Zone as a target. Under a blanket saturation of incendiary and high-explosive ordnance, 1,000-degree firestorms instantly remelted Honda's prized precision lathes, casting furnaces, and a decade's worth of metal tooling into twisted slag entirely devoid of tolerances. Honda attempted to salvage the surviving equipment by setting up a new plant in Iwata, but the Earth's fault lines delivered the ultimate betrayal. On January 13, 1945, the 7.1 magnitude Mikawa earthquake struck. The violent geological shearing obliterated the load-bearing structures of the Iwata facility, and the collapsing plant crushed Honda's last remaining physical assets. In less than 12 months, the fires of war and the tremors of geology executed a total physical wipe of Honda's accumulated wealth. In August 1945, staring down a wasteland of scorched rubble, this hardcore gearhead displayed an extremely unorthodox strain of resilience. He didn't break down in tears over the ruins, nor did he issue rallying cries for a comeback. With absolute detachment, he liquidated the bombed-out debris and his remaining shares, selling them to Toyota at a severely discounted flat rate of 450,000 yen, executing a clean physical sever from his past. At a time when post-war Japan was teetering on the edge of mass famine and the population was fighting for mouthfuls of black-market rice, Honda took his severance pay and executed a highly absurd maneuver. He bought a massive industrial gasoline drum and filled it to the brim with high-purity, medical-grade alcohol. For an entire year, he completely severed his connection to the mechanical world. Holed up in a shack, he synthesized cheap shochu and whiskey from the medical alcohol, drank himself into daily blackouts, and played the bamboo shakuhachi. He labeled this 365-day total shutdown a human holiday. This wasn't some romantic period of latency. It was a forced system cooldown and physical hibernation for a bottom-tier mechanic whose neurological and physical bandwidth had been maxed out by metal fatigue and the extreme pressure of war. However, the base code hardwired into his system was something alcohol couldn't format. In 1946, the shutdown ended. Japan's infrastructure was completely leveled. Train networks were offline, and gasoline was under strict military rationing. The lower-class population had to rely exclusively on their legs or manual pedal power on bicycles, grinding out treks of tens of kilometers to the countryside just to barter for calories. Amidst this extreme commuter deadlock, Honda was visiting a friend when he caught sight of a dust-covered warehouse. Stacked in the corner were 500 abandoned Mikuni No. 6 micro-gasoline generators left over from the defunct Imperial Japanese Army. These 50 cubic centimeter two-stroke units were crude and unsophisticated, never engineered to generate vehicular propulsion. Their sole operational envelope during World War II was providing power to portable military radio rigs across off-grid, scorched earth combat zones. But to the eyes of this newly sobered mechanic, the gears aggressively synced up once again. The generators were an off-the-shelf powertrain. Bicycles were an off-the-shelf chassis. Powertrain plus belt drive equaled the motorized transport the lower-class demographic desperately needed. Honda immediately acquired this military scrap. To bypass the fatal constraint of gasoline shortages, he tore open the carburetors and applied brutal physical re-engineering, forcibly altering the air intake and fuel injection parameters. This allowed the finicky generators to combust a hybrid mix of pine root oil extracted from tree stumps. Though this highly impure, degraded fuel caused severe engine carbon buildup, when survival is the metric, as long as the machine turns over, all physical trade-offs are acceptable. Using the most primitive rubber belts, he strapped these military radio generators to the rear wheels of bicycles, assembling loud, black smoke-belching rigs nicknamed Bata Bata. This low-cost mobility solution, cobbled together from wartime trash, instantly detonated within the low-income market and sold out immediately. In September 1946, inside a 16-square-meter wooden shack in Hamamatsu, built on the ruins of a textile dye plant, Soichiro Honda used a brush to paint the characters for Honda Technical Research Institute on a piece of wood and hung it outside the door. Today's Honda empire, commanding dozens of top-tier clean-room manufacturing plants globally and dominating engines across land, sea, and air, did not have its reboot sequence coded in a Wall Street PowerPoint. It spawned in a 16-square-meter shack, built from a few hundred scrap generators originally meant to transmit war telegraphs, set against the lingering stench of medical alcohol. The 500 Imperial Army radio generators Honda scavenged in 1946 allowed him to clear the first survival tier in the ruins. But you don't construct empires by salvaging trash. By 1947, the supply of these kit-bashed war relics hit zero, forcing Honda onto a ledge. Either shut down operations or start from absolute zero and build engines in-house. He chose the latter. Within that 16-square-meter shack on the dye plant footprint, Honda manufactured his first purely self-developed engine, the Honda A-Type. This 50 cubic centimeter unit was exceedingly primitive. To prevent the exhaust pipe from burning the rider's legs, it was routed straight up into the air, resembling a crude smokestack. Lacking any modern acoustic suppression, it generated a deafening metal-on-metal bata-bata clatter while running. Its output was anemic, and its aesthetics were raw. But in a decimated Japan, where public transit was fully paralyzed, this black smoke-spewing smokestack engine was the only mechanized platform the working class could finance. In 1948, Honda Motor Company officially incorporated, with an initial capital footprint of just 1 million yen. Soichiro Honda's objective vector shifted. He no longer wanted to simply provide cheap commuter tools. He intended to establish an irreversible industrial standard. In 1952, Honda dropped the Cub F-Type, a machine that would be hard-coded into the history of industrial design. To minimize the payload on bicycle frames, Honda pushed engineering limits to the absolute edge, compressing the dry weight of this 50 cubic centimeter engine to a staggering 7 kilograms. Simultaneously, Honda entirely re-architected the physical flaw of side-mounted engines, which had a habit of discharging exhaust and oil onto riders' pants, by slinging it underneath, executing a flawless fix to the contamination issue. The real kill shot was its visual anchor. In a post-war landscape dominated by gray, rust-covered industrial decay, Honda deployed extreme visual aggression. The engine was painted a high-visibility, piercing red, paired with a pure white teardrop external fuel tank. This aggressive aesthetic configuration of the white tank and red engine acted like a brand, instantly establishing itself as the most dominant mechanical signature on the streets of Japan. Yet, regardless of how hardcore the hardware is, it remains vulnerable against monopoly capital. At the time, Japan's motorcycle distribution pipelines were completely locked down by massive distributors backed by conglomerate capital. These giants relentlessly squeezed new, unbacked players like Honda, demanding rock-bottom wholesale rates and punishing multi-month payment cycles. Refusal meant a severed distribution pipe. Submission meant Honda's fragile cash flow could face a hard physical break at any moment. Facing asphyxiation from monopoly channels, Soichiro Honda and his partner Takeo Fujisawa made an incredibly hostile decision. Flip the table entirely. They fully abandoned legacy motorcycle distribution channels and locked their targeting parameters onto a baseline network completely unpenetrated by automotive capital. Bicycle repair shops. In Japan at the time, there were 50,000 such shops scattered nationwide. In 1952, an era devoid of automated printing and email, Honda initiated an unprecedented human algorithm. They mobilized every employee, hired freelance copyists, and even dragged bank tellers in to help, relying on pure manual labor to handwrite 50,000 letters, word for word, and mailed them directly to bicycle shop owners across Japan. The letter contained zero corporate filler, only raw survival stakes and the logic of asymmetric warfare. Your ancestors established your current business by selling imported bicycles after the Russo-Japanese War. But today, the consumer requires bicycles equipped with engines. Honda has built that engine. This massive gamble broke the historical ceiling for conversion rates in commerce. Honda quickly received responses from over 30,000 bicycle shops. Filtering the data, Honda locked in 13,000 shops as their Tier 1 authorized network and pioneered a 12-month installment plan for lower-income consumers. The output was thermonuclear. Within a few months, monthly dispatch volumes for the Cub F-Type breached 9,000 units. Honda didn't just evade cash flow death. This bottom-tier mechanic, once coated in industrial grime, utilized a stack of handwritten envelopes and a 7-kilogram red engine to completely shatter the giant's channel monopoly, forcibly rewriting the source code of grassroots distribution. Once Soichiro Honda used handwritten letters and red engines to unify the muddy streets of Japan's working class, his ambitions exceeded the island's borders. No longer satisfied with manufacturing cheap commuters, he declared war on the power centers of global heavy industry. For Target 1, he selected the Isle of Man TT, the most lethal, blood-soaked motorized meat grinder on the planet. The circuit was a 60-kilometer stretch of closed public roads with zero runoff areas, flanked only by unyielding stone walls, utility poles, and cliff drops. When Honda announced their entry in 1954, legacy European manufacturers like Italy's MV Agusta and Germany's NSU didn't even register this Asian workshop on their radar. In the face of hard physical telemetry, arrogance has a baseline. At the time, the peak output of Honda's engines was barely 1/3 of the European Dominators. The Europeans possessed decades of fluid dynamics and specialized metallurgy data. Honda had nothing. Confronted with a massive technological deficit, Soichiro Honda executed an extremely violent engineering solution. Forcefully redline the engine RPMs. Since the displacement was hardware-locked by regulations at 125 cubic centimeters, the only way to extract horsepower was through extreme piston stroke frequencies. Honda engineered a 125 cubic centimeter twin-cylinder DOHC engine for the RC142 race bike, forcibly driving the tachometer up to a bone-chilling 13,000 revolutions per minute. It was a suicide run against the physical fatigue limits of metal. In early dyno testing, the cast iron available in Japan simply could not withstand the terrifying centrifugal forces and friction heat generated at 13,000 revolutions per minute. Connecting rods snapped constantly, punching straight through engine blocks. Pistons melted down completely inside cylinders under hundreds of degrees of heat. When an engine blew and seized, Honda wouldn't even wait for a cool down. He charged in directly, using his calloused hands to grab the metal shrapnel exceeding 100 degrees in temperature. He required the primal tactile feedback of his fingers against the sheared metal cross-sections to process the physical failure logic of molecular fracture. By grinding through these hardcore, flesh-burning analytics, the impossible occurred. In 1959, Honda made their Isle of Man debut, securing 6th, 7th, and 8th place. A mere 2 years later, in 1961, Honda's engines had achieved a terrifying evolution in RPM output and durability, completely sweeping the top 5 positions in both the 125 cubic centimeters and 250 cubic centimeters classes at the Isle of Man TT. On the deadly circuit the Europeans prided themselves on, Japanese internal combustion executed a merciless technological slaughter. But track trophies were merely tools to harvest technical telemetry. Honda's true kill target was the largest consumption matrix on the globe, the United States. In 1959, a few Honda personnel leased a rundown storefront on Pico Boulevard in Los Angeles, officially making landfall in North America. The U.S. motorcycle market at the time was under the absolute hegemony of heavy V-twin platforms from Harley-Davidson and British Triumph. The heavy motorcycle clutches of that era required massive grip strength and suffered from severe physical oil leaks. Even more lethal was the demographic firewall. Conditioned by Hollywood film reels, the motorcycle was hard linked in the American psyche to the tags of leather jackets, biker gangs, and outlaws. The middle class, college students, and women were entirely fenced off, physically and psychologically. Confronted with the mechanical juggernauts of Detroit and Milwaukee, Honda didn't engage in kinetic, head-on warfare. Instead, they rolled what looked like a non-lethal plastic toy out of the shipping container, the Super Cub C100. It was an asymmetric harvest that defied all American motorcycle operational doctrines of the time. While Americans were still enduring the high decibels and blue smoke of two-stroke rigs, Honda dropped an exceptionally quiet, clean-burning 4-stroke single-cylinder engine into this 50 cubic centimeter lightweight. It deleted the left-hand clutch lever, opting for a centrifugal semi-automatic transmission. Anyone who could step on a pedal could launch it. It utilized a U-shaped underbone frame, allowing women in skirts to operate it without swinging a leg over. and the front was equipped with a massive white plastic leg shield, entirely blocking any oil blowback from the engine. The most lethal physical strike, however, was the price tag: $295. That didn't even cover the rounding error on a Harley. To aggressively purge the outlaw tag from motorcycles, Honda initiated a phenomenal cultural overwrite across the U.S. in 1963. They deployed the historically hard-coded copy, "You meet the nicest people on a Honda." The visual assets featured zero ink and zero leather. Instead, the frame was filled with college kids in clean sweaters, housewives running errands, white-collar workers with briefcases, and middle-class golfers carrying their clubs. All smiling, navigating through the sunlight on spotless Super Cubs. It was a flawless execution in commercial history. Honda forcefully downshifted the motorcycle from a heavy toy for outlaws to a lightweight appliance for standard Americans. The Super Cub blew up instantly in the U.S., ultimately logging over 100 million units in global volume, establishing it as the highest-selling motorized transport in human history. The titans at Harley sat in their wide leather executive chairs, watching helplessly as the Japanese mechanic who once scrubbed waste oil from Tokyo dirt roads carved out a multi-million user empire right out from under them, armed with a $295 plastic scooter lacking a clutch. By the early 1960s, Honda was the largest motorcycle manufacturer on Earth. But the underlying logic of a gearhead is to constantly scale toward higher complexity physical architectures. Soichiro Honda made the call to build automobiles. Before crossing into the four-wheel domain, the initial friction didn't come from Detroit, but from the administrative chokehold of the Japanese government. At the time, Japan's Ministry of International Trade and Industry, MITI, was drafting the Specific Industry Promotion Law, attempting to use administrative protocols to hard-lock the automotive entry list. The bureaucrats operated on highly rigid logic. Japan already possessed Toyota and Nissan. Allowing a motorcycle plant like Honda to force its way into car manufacturing would only yield a waste of domestic resources. Faced with the administrative interference of the state machine, Honda didn't deploy PR lobbyists. He stormed directly into the MITI building and roared at the suited high-level officials. "Government bureaucrats need to get out of my way. What qualifications do you have to dictate who gets to build cars?" He completely bypassed the legislation's progression, immediately spinning up the assembly lines and forcefully dropping the T360 micro truck and the S500 sports car onto the grid before the ban could activate. He used the physical reality of hardware in production to aggressively tear open an access badge to the Japanese auto industry. But the battlefield that truly elevated Honda automobiles to God-tier status was across the Pacific, on the North American continent. In 1970, Los Angeles was suffocating under severe automotive photochemical smog, turning the sky a highly toxic yellow. As a result, the U.S. Congress enacted the ruthlessly strict Muskie Act, Clean Air Act extension. The mandate was absolute. By 1975, hydrocarbon and carbon monoxide emissions on all new vehicles had to be slashed by 90%. Detroit's Big Three, GM, Ford, Chrysler, were furious. CEOs and top-tier engineers slammed their fists on tables during congressional hearings, declaring that based on the physical properties of the internal combustion engine, cutting emissions by 90% was an unexecutable sci-fi fantasy. If enforced, the U.S. auto industry would suffer a total system halt. At the time, the only available workaround was bolting on highly beta-stage catalytic converters, components that clogged easily, demanded scarce unleaded fuel, and carried the physical risk of igniting vehicle undercarriages at high temperatures. While Detroit Titans burned massive capital lobbying Congress to patch the legislation, Honda's engineers operating in the lab cracked this physical dead end, rolling out CVCC, compound vortex-controlled combustion technology. It was textbook ground-level mechanic logic. If the exhaust pipe can't filter the pollution, solve it at the source block, the combustion chamber. In a legacy cylinder, if the air-fuel mix is too rich, it pollutes. If it's too lean, the spark plug fails to detonate. Honda's physical hack was this: integrate a micro pre-chamber at the top of the main cylinder. The carburetor injects a high-density fuel mixture into the pre-chamber, while simultaneously injecting an extremely lean fuel mix into the primary cylinder. The spark plug ignites the pre-chamber, and the rich gas instantly detonates, translating into a high-pressure flame jet that fires into the main cylinder like a torch, immediately igniting the lean gas that previously wouldn't spark. The telemetry was disruptive. The gasoline was squeezed and burned down to zero residue. Requiring no expensive hazardous catalytic converters and entirely indifferent to fuel octane grades, Honda's CVCC engine blew straight past the limit testing of the Muskie Act. When Honda open-sourced the data on this tech, Richard Gerstenberg, the chairman of GM at the time, issued an arrogant public sneer. "I have looked at this design. While it might work on those little toy motorcycle engines of theirs, I see no potential for it on one of our GM car engines." Registering the GM CEO's mockery, Soichiro Honda executed the most hardcore revenge sequence in automotive history. He quietly deployed operatives to the U.S. and used out-of-pocket funds to purchase a 1973 Chevy Impala, a chassis running GM's pride and joy, the 350 cubic inch, 5.7-liter V8 engine. Honda shipped this American heavy cruiser back to their Japanese labs, where engineers immediately stripped the cylinder heads and intake manifolds off the GM block. Operating on the base protocols of CVCC, they cast entirely new cylinder heads featuring the pre-chamber specifically for this 5.7-liter American behemoth. Once the retrofit was complete, Honda covertly shipped the Chevy V8, now running on a hacked CVCC heart, back to the U.S. and drove it straight into the official EPA emissions testing lab in Ann Arbor, Michigan. The output data hit Detroit's jaw like a kinetic strike. The Honda-modified GM V8, completely stripped of any exhaust aftertreatment hardware, flawlessly cleared the punishing emissions standards, with zero negative delta in fuel consumption. Honda slapped the official testing documents directly onto GM's desk. The Detroit executives were rendered speechless. Ford and Chrysler were forced to drop their heads and transfer massive patent licensing fees to Honda to acquire the tech. But what truly signaled sunset for Detroit was the ultimate judgment of the macro cycle. In October 1973, the Yom Kippur War ignited. OPEC activated an oil embargo, and the first global oil crisis detonated. U.S. gas prices quadrupled overnight, generating miles-long vehicle queues outside gas stations. Those American full-size cruisers running 5.0-liter and 7.0-liter V8s, burning through 20 to 30 liters per 100 kilometers, instantly degraded from status symbols into highly useless iron scrap. Right at the moment American commuters hit a physical dead end, the CVCC-equipped Honda Civic made landfall in North America at scale. Built on a simple, ultra-reliable architecture and leveraging lean burn tech, it logged terrifying fuel efficiency metrics of 40 miles per gallon, around 5.8 liters per 100 kilometers. In Los Angeles and New York, the queues to buy a Honda Civic eclipsed the queues to buy gas. half a century. The 15-year-old apprentice who scrubbed waste oil off the rough concrete of a Tokyo repair shop, strapped with a baby and coated in industrial dust, ultimately used an indestructible civilian engine to force Detroit's century-old automotive empire to bow its head.